Do you feel frustrated, unprepared, confused, or lost? Well, it's time to be happy because Geography World Channel is here to help. A big shout out to Ashley Silent, who is a student of Belmont Academy located in Westmoreland, Jamaica. Now, a fun fact is that Belmont Academy is located directly across from the Caribbean Sea. Oh, what a sight that must be! I see the comments and requests and I will act on them. Please remember to follow Geography World channel on Instagram and Facebook using the link shown on the screen. Please remember to like, share with your friends and subscribe. For person wishing to contact me privately, you may email me at geographyworld100@gmail.com. The link will be posted below. Welcome back to Geography World channel. For this video, we'll be looking at the May-June 2016 paper. Now, the May-June 2016 paper and the papers dated back then, they're a bit different from the paper that you'll receive in 2021. Now, the difference is that this paper, it has 10 questions in 4 sections. So, section 1 is the map reading question and it's compulsory. And then in section B to D, you have 3 questions in each section and you were to choose one. However, the paper that you'll receive, if you have watched my previous videos, you would have noticed that you get it in 4 different sections, but each section you have 1 question and you must answer all questions in order to get maximum marks. So for this video, we're going to go through all of the questions in section B, that's the natural system or the physical section. So the first question, it asks us to draw a diagram to show the formation of a spit. Now, a spit is a narrow or extended stretch of sand or pebble that juts out into the sea from the land. Now, how is a spit formed? It is formed when sediments transported along the coast by longshore drift is basically deposited at a bend in the coastline. Now, over time, the sediments along the bend will gradually extend into the sea at the point where the coastline changes its shape. So if you look closely at the picture, you can see the bend. So that bend that you're looking at, that is the spit. Section B, part 1 asks you to define the term soil creep. Now, soil creep is just the slow, gradual, but continuous movement of soil down a slope. So, soil creep is the slow, gradual, but continuous movement of soil down a slope. Now, part 2 asks us to state 2 indicators that soil creep is occurring on a slope. Now, we don't know, soil creep is happening so slow that it is not visible. So we're not seeing when the soil is actually creeping, but there are signs that you can look out for. So we can look out for the tilted trees or fences. We can look for tension gashes in the roads. We can look for the accumulation of soil at the foot of a slope, and we can look for the thinner soil at the top of the slope. Once we see any of those 4, it means that the soil creep is actually taking place. So we can look out for tilted trees or fences, tension gashes in the road, the accumulation of soil at the foot of a slope, or thin soil at the top of the slope. Part 3 asks us to list 4 human activities that contribute to landslide in the Caribbean. Now, 4 human activities: mining, excavation, deforestation, the development of infrastructure on the slope, and to some extent farming. You can basically list any four. So let me go over mining, excavation, deforestation, development of infrastructure on slopes, and farming. These are just a few of the human activities that contributes to landslide in the Caribbean. Question C, part 1, asks us to explain how earthquakes occur at transform plate boundaries. Now, at transform plate boundaries, the two plates are sliding past each other. Now, as the plates rub against each other, they may become stuck or they stick onto each other. Now, where they are stuck to each other, pressure and stress will build up. Now, when enough pressure and strength and stress is built up, they will snap apart. And when they snap apart, the energy will be released. And this is where we will have the earthquake taking place. Part 2 asks us to account for the formation of fold mountains and volcanoes at destructive plate boundaries. Now, another name for the destructive plate boundaries are convergent plate boundaries. Now, fold mountains, they are formed in two ways. So, one is that when they are formed when two continental plates converge or come together. So when they collide, they are forced upward into a fold, and they're also created where two or more of the Earth's tectonic plates are pushed together. Now, as they collide or compress, boundaries, rocks, and debris are wrapped and fold into rocks and outcrops, hills, mountains, and entire mountain ranges. Now, as it relates to how volcanoes are formed at divergent plate boundaries, they are formed when the continental and the oceanic crust meets. So the oceanic crust is denser than the continental crust. So the oceanic crust subducts beneath the continental crust, and the oceanic crust, it will return to the mantle or the asthenosphere where it will melt. And along that area, we have the subduction zone. Now, along the subduction zone, volcanic island arcs can develop, has the potential to develop along the subduction zone. Question 3 asks us to draw a sketch map of Barbados or Jamaica, and on the sketch map we're to shade an extensive area of limestone. Now, the first thing you need to do is determine which one of the countries you're going to draw first. Is it Barbados or is it Jamaica? Now, after determining which one you're going to draw, you need to ensure that your sketch map has all 5 elements of a map. So your sketch map should have a key, a scale, a compass point, it should have a title, and it should have a border. Now, this is a map of Jamaica, and it is showing you the location of limestone in Jamaica. Now, the yellow shows us where we have yellow limestone. So this area, yellow limestone, and the white or the pale blue shows us where we have white limestone. So all this area, these are areas that we have white limestone. And this blue here along St. Thomas and Portland there and the North Coast and Western Jamaica, it shows us the coastal group of limestone. So once you are able to shade or basically indicate on the map an extensive area of limestone, which could be the entire section of central Jamaica, then you would get your 4 marks alongside your elements of the map on the map. Now, for the candidates who want to do limestone in Barbados, the yellow, pale yellow, it shows us the coral rocks, and in other words, it shows us where we have coral limestone. So along this section, all of these areas where we have limestone rock. So once you're able to shade most of this section, then you're pretty on your way to receiving the full 4 marks. And once you put in the 5 elements of the map, The 4 marks is yours with the shading. Now let's get back to the question. Question B, part 1, asks us to describe the formation of a waterfall in areas where there are alternate layers of hard and soft rocks. Now, in areas of alternate layers of hard and soft rocks, the soft rocks, they'll be easily eroded, right? So what happens is that the waterfalls, they are formed when a river flows over a layer of hard rock. The hard rock is resistant, so it erodes slower than the soft rocks below it. So the soft rocks, they're on top, they will erode quickly to leave just the hard rock. Now, the hard rock will basically form a steep edge over which the water will fall. Now, gradually, the waterfall will basically dig out the pool at the base, right? So vertical erosion will take place to form a plunge pool. Part 2 asks us to describe the process of frost shattering. Now, frost shattering is basically, it's also called freeze thawing, and this happens when water seeps into the cracks in the rocks. Now, the water, it freezes at night and when it's cold, right? So at night it's cold, the water freezes, and it thaws during the day when the time is warm. So what is happening is the constant freezing and thawing will eventually lead to the rock breaking apart. Question C, part 1, asks us to explain how rock structure and chemical composition influences the weathering of limestone. Now, the structure of the limestone rock, it basically influences chemical weathering because due to its distinct layers and cracks, it makes it very, very easy for water to get into the cracks. Now, this allows carbonation to take place easily due to the permeability of the rocks. Good, so the cracks, the structure, we talked about the cracks in the rock, it allows rainwater to actually be trapped. So it's easy for rainwater to be trapped in the different cracks and joints. Now, as it relates to the chemical composition of limestone, it is important because limestone, they're made up of more than like 80% of calcium carbonate. Now, in order for carbonation to take place, calcium carbonate is required, and limestone is a very good carrier of calcium carbonate, right? So remember, it has more than 80% of calcium carbonate, thus it basically facilitates the carbonation process. Part 2 asks us, with the help of a diagram or diagrams, that we explain the formation of pillars in limestone areas in the Caribbean. Now, a pillar, it's an underground feature, and it is formed when the stalagmite forms the stalagmite, it forms directly below a stalactite. So the stalagmite forms on the cave floor and the stalactite forms in the ceiling. So as the water drips from the ceiling of the cave onto the floor, right, the stalactite is formed, and the water will harden in the ceiling to form the stalactite. Now, the stalactite may continue to grow downward and the stalagmite may continue to grow upward until the two limestone features eventually meet. When they eventually meet, they form what we call a pillar or a column. Question 4 shows us the number and cost of floods, droughts, and hurricanes worldwide, and we're to answer the questions that follow. So it shows you the year or the period in this time. It shows you the number of major events within that period as well as the cost, right? So part 1 asks us to identify the period which had the highest cost per event. Now, in order for us to get the highest cost per event, what we would have to do is to divide the event into the cost, right? And when you do that, you would realize that in 1990 to 1999 had the highest cost per event. Good? So they had the highest cost per event. Because when you divide 629 into 89, you would have gotten 7.06. So it means that for every event, 7.06 billion was spent, right? When you divide the other figures, you would get lower figures. So it was 1990 to 1999. Part 2 asks us between which two period was there the highest increase in the number of events. So the number of events increased between 1970 to 1979 and 1990 to 1999. So that was the biggest increase. Those two had the biggest increase. Now, part 3 asks us to outline two trends in the data presented in the table. So trend 1 is that as the year progressed, the number of events increased. So look at it. So in 1969 to 69, we had 27 events. Now, as the periods progress, so does the amount of natural events. Good. And the second trend is that as the year progressed, the cost per event increased. Now, there's 73 for the first period, 131 for the second. If you realize, as the periods progress, the cost also progress. All right, so part B, question 1 asks us to state 4 characteristics of weather associated with the passage of a tropical wave. Now, the weather that are associated with a tropical wave include they have moderate winds, there is heavy and continuous rainfall, we have overcast skies, and the temperatures they usually remain high. We are part 2 now asks that for areas within a tropical marine climate, we're to outline 2 characteristics of rainfall and 2 characteristics of temperature. So let's start with the rainfall. So the characteristics of rainfall in the tropical marine climate is that it is seasonal, right? So we have a distinct wet period, which is usually between June to November, which is what we call our hurricane season. In the tropical marine region, we often receive relief rainfall because of our location, and the rainfall annually is between 1,200 to 2,000 millimeters. As it relates to the temperature, the 2 characteristics are that the temperatures, they remain high all year round. Temperatures are usually between 28 degrees Celsius to 30 degrees Celsius all year round. There is a distinct dry season, usually between December and May. Question C asks us to compare 3 adaptations of vegetation to the climate in the equatorial and the tropical continental region. We're to include reasons for each adaptation. So this is a 12-mark question. You're expected to write an essay and you're to include your reason. Let's look at the equatorial region first. So some of the adaptation of the vegetation is that there is dense layer of tall trees that form a canopy over the top with less dense layers of trees below, right? Now, the rainforest, it has evergreen appearance. The trees, they have large leaves, very tall trunks, and very large buttress root to support their tall trunks, right? So the trees in the equatorial region, they have very large leaf because of the amount of rainfall that the area receives. So they have adequate amount of water to help with their growth. They have very, very tall trunks, slender and tall trunks, because they don't have to store water like other plants within other regions because of the temperature and the rainfall that we experience in the equatorial region. And they have large trunks to basically help, large roots, sorry, to basically help to support their tall trunks. Now, in the equatorial region, many vines and the plants, parasitic plants, they basically live on the trees so that they're able to reach sunlight and nutrients as well. Because of how tall these trees are, they cover, so the emergent layer and the canopy layer, they basically cover all the other layers. So other plants, their growth will be stunted because they don't receive enough sunlight. Now in the tropical continental region, the trees here, or the plants here, they have deep roots that basically tap into underwater supply, right? So when it's a dry season, the deep roots, they tap into the underground water supply to basically sustain themselves. Some of these plants are deciduous in nature, meaning that they shed their leaf during the dry season. Some of these trees, they grow to a height of about 3 to 5 meters because of the temperature in the region, because of both the wet and the dry season. They have huge trunks or big trunks, and they use their trunks as a way of storing water for the dry season. And they usually have small thin leaves that basically aid in the reduction of transpiration in the dry season. So answering that question you would have earned 24 marks. So for this section, you were only to choose one, right? If you were doing the exam in 2016. We are at the end of this video. Thank you for watching, and please remember to like, share, subscribe, and turn on your post notification bell in order to receive more videos like these. Leave comments below suggesting topics that you would want me to present on. In the comment section below, comment the name of your school and the territory for a shout out in my next video. Until then, bye!